In chemistry, we can use words, but we prefer to use symbols and formulae as it's quicker and more efficient. Every element has a chemical symbol, and it's usually one or two letters. For example, hydrogen is just H, whereas helium is He. The first letter is always a capital, and if there's a second letter, it's always lowercase. Some of them are really easy because it's just the first letter of the name of that element. For example, oxygen is O, carbon is C, and phosphorus is P. But sometimes they are completely different. Sodium is Na, and potassium is K. The capital matters. Capital C, capital O is a toxic gas called carbon monoxide, and capital C, lowercase o is the metal element cobalt. Now let's talk formulae. All right, a chemical formula tells you which elements are present and how many atoms of each element. Take H2O, for example. The small number is called a subscript, and it tells you how many atoms there are. So the 2 means there's 2 hydrogen atoms. And if there's no number, it just means there's 1 atom of that element. So here there's 1 oxygen atom. So sulfuric acid has the formula H2SO4. So that means there are 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms.
Metals are on the left of the periodic table. Non-metals are on the top right. When a metal reacts with a non-metal, they form a compound. Naming these is easy if you follow this rule. First, say the metal name exactly as it is. Then change the non-metal ending to IDE, ide. So if sodium reacts with chlorine, you get sodium chloride. Magnesium and oxygen would make magnesium oxide. And zinc and sulfur would make zinc sulfide. Metal first, non-metal second, ending becomes ide, boom. But not all compounds end in ide. Some compounds contain a metal and a group made from a non-metal and oxygen. That group stays together and acts like one thing. When this happens, the name ends in ate. You can remember this by thinking that the non-metal has eaten or combined with the oxygen. For example, zinc and sulfur makes zinc sulfide, but when zinc combines with sulfur and oxygen, it gives you zinc sulfate. Aluminium and nitrogen would make aluminium nitride, but aluminium with nitrogen and oxygen makes aluminium nitrate. The common ones you need to recognise are carbonates, nitrates and sulfates. When you see these names, oxygen is part of the group. Carbonates contain CO3, nitrate contains NO3, and sulfate contains SO4. For example, calcium plus the carbonate group gives you calcium carbonate, sodium plus the nitrate group gives you sodium nitrate, and copper plus the sulfate group gives you copper sulfate. Okay, when 2 non-metals react, remember they're on the top right of the periodic table, they form a covalent compound. Here the name can tell us how many atoms are present. We do this using number prefixes. Mono means 1, think monorail or monobrow. Di means 2, think dilemma, a difficult choice between 2 options. Tri means 3, think tricycle. Let's look at carbon and oxygen. 1 carbon and 1 oxygen is carbon monoxide. Mono tells us there's 1 oxygen. 1 carbon and 2 oxygens would therefore be carbon dioxide. Di means 2, so 2 oxygens. So SO2 is sulfur dioxide and SO3 is sulfur trioxide. Some important covalent compounds you just need to learn are water, H2O, you should know that one. Ammonia, NH3, used in making explosives and fertilizers, and methane, CH4, which you find in natural gas. Hydroxides. Some compounds contain a metal and the OH group. These are called hydroxides. The naming rule is simple. Metal name first, then hydroxide. For example, sodium plus hydroxide gives you sodium hydroxide. Potassium plus hydroxide gives you potassium hydroxide. Now let's look at acids. All acids contain hydrogen. Not everything that contains hydrogen is an acid, but all acids do contain hydrogen. You just need to learn these common ones. Hydrochloric acid is HCl. Sulfuric acid is H2SO4. And nitric acid is HNO3. Okay, so you should now know how to name compounds. But when we write chemical equations,
we also need to know what those substances actually look like. In symbol equations, we get clues. They're called state symbols. State symbols tell you the state a reactant or product is in. They are written in brackets. S for solid, L for liquid, G for gas, and AQ for aqueous, which just means dissolved in water. The difference between liquid and aqueous, this is where everyone gets very confused. These are not the same thing. So let's fix this now for good, using salt as an example. This is solid sodium chloride, the white crystalline salt you put on your chips. It's a pure compound. When it's aqueous, this is what you get when salt is dissolved in water. It's literally a mixture of salt and water. This is liquid sodium chloride. You only get this by heating salt up to over 801 degrees C. It's still a pure compound. There's nothing else there, no water to be seen. Liquid sodium chloride is often described as molten because in chemistry, liquid and molten mean the same thing. It's when a substance has been heated above its melting point but not boiled. So to recap, if it's liquid, it's pure. If it's aqueous, it's dissolved in water. It's a mixture of their substance with water. Okay, let's apply our knowledge to predict what we'd see in a couple of situations. So looking here, we've got sodium chloride as a solid going to aqueous sodium chloride. This tells you the solid has dissolved. In order for this to happen, water would have been added. No new substance is formed. What would you see? The solid would disappear because the particles become so spread out and so small, light can no longer bounce off them. That makes this a physical change. And physical change is one where no new substances are formed. Now let's look at this reaction. Zinc plus hydrochloric acid goes to hydrogen plus zinc chloride. The fact that there's a gas in the product tells us that we'd see fizzing, bubbling, or effervescence. They all mean the same thing. New substances are made. That means this is a chemical change. Final example, this is the test for carbon dioxide. When lime water reacts with carbon dioxide, a solid is formed in the solution. This is called a precipitate, and this would result in the solution going cloudy. This is always the case when solutions go cloudy. Solids or precipitates have been formed.